Hey everyone, and welcome to another deep dive with us. Today we're taking on a concept that's, well, it's a little mind-bending to say the least.
It really is.
I'm talking about superposition.
Yes, superposition.
Ever feel like you're in two places at once?
Uh,
Well, it's kind of the reality in the quantum world, and to guide us on this journey is an excerpt from an article we found
oh,
fascinating.
absolutely.
It's by Jorgo Schneeppert, and it's called
Überlagerung,
Überlagerung,
which means superpositions.
superposition, basic principle of quantum mechanics.
Exactly right.
So not just a busy schedule then.
Well, not quite. It challenges how we see reality, really.
Okay, so let's break this down.
Sure.
What does superposition actually mean in the quantum world?
Imagine a spinning coin.
Okay.
Before it lands, it's not heads or tails. It's both possibilities existing at the same time.
Huh.
And that's superposition in a nutshell.
Okay.
It's a state where a quantum object, like an electron, can exist in multiple states simultaneously
Simultaneously.
until it's measured.
So it's like wearing all your clothes at the same time, just in case you need to change for any occasion.
Haha, that's one way to put it.
Quantum fashion must be a nightmare.
But seriously, this idea of multiple coexisting states,
Right.
it's really jarring compared to our everyday experience where things are generally in one definite state.
For sure.
You know what I mean?
Yeah.
Like this table is a table.
It is.
It's not also a chair or a cat at the same time.
Yeah, you don't come home and the table is suddenly turned into a cat.
Not usually, no. But in the quantum world, things are a bit more fluid.
Yeah, a bit more fluid.
And this is where superposition comes in.
It definitely is. I remember reading about the double slit experiment in school, and that was my first encounter with quantum weirdness.
Ah, yes, the double slit.
Electrons acting like they're going through two slits at once.
Exactly. It's a classic example of superposition in action,
Right.
and one that Jorgo Schneeppert highlights in his article.
Okay, cool.
So what's fascinating here is that electrons fired at a screen with two slits create an interference pattern like waves,
Yay.
implying they're going through both slits simultaneously.
Wow.
But the moment we try to observe which slit each electron goes through,
Right.
this wave-like behavior vanishes.
So they're like, hey, no peeking. We only do the cool stuff when no one's looking.
Uh-huh.
Seriously, though, does the act of observation really change reality at the quantum level?
That's a question that has puzzled scientists for decades.
Yeah.
And Schneeppert grapples with it too in his article.
Okay.
And this is where the concept of wave function collapse comes in.
Okay.
The wave function is a mathematical description of all the possible states a quantum system can be in, like
Wow.
our spinning coin being both heads and tails.
Okay.
But when we make a measurement,
Right.
this wave function collapses,
Okay.
and the system chooses a single state.
So this is where I start to lose my grip on reality a little bit.
I can understand that.
Is it like the electron is actually in all those states at once, or is this just a mathematical way of describing our uncertainty?
It's not just uncertainty.
Okay.
The electron really is in all those states simultaneously described by its wave function.
Right.
The act of measurement forces it to settle into one specific state, and that's what we observe.
Okay.
So imagine you have a deck of cards spread face down.
Okay.
That's the wave function representing all the possibilities.
Okay, good.
When you pick a card,
Yeah.
you make a measurement, the wave function collapses, and you're left with that one card, a single state.
Okay, that card analogy helps, but my brain is still doing backflips trying to picture this.
It's a tricky concept, for sure.
It's almost like the electron is making a decision when we observe it.
In a way, yes.
Is there a way to predict which state it will choose?
We can't predict with certainty which specific state the electron will choose.
Okay.
But the wave function gives us the probabilities of each possible outcome. So we might say there's a 70% chance it will spin up and a 30% chance it will spin down.
Right.
But it's only upon measurement that the decision, so to speak, is made.
So it's like rolling a weighted die.
Exactly.
You know the odds, but you can't know the outcome for sure until it lands.
That's a great analogy.
This is where I start to wonder if quantum mechanics is more like philosophy than physics.
It certainly blurs the lines.
It really does.
But let's remember, this isn't just some theoretical abstraction.
Right.
Superposition has real-world implications,
Okay.
especially when it comes to quantum computers.
All right, so we've established that superposition is pretty wild.
Definitely.
But how does it actually power these super machines? It's not like they're running on tiny spinning coins, right?
Not quite,
Right.
but the analogy of the spinning coin being in both states at once is a good starting point.
Okay.
Think of it this way. A normal computer uses bits, which can be either 0 or 1. It's like a light switch being either on or off. A quantum computer uses qubits, which can be 0, 1, or both simultaneously thanks to superposition.
Okay.
It's more like a dimmer switch that can be set to any level of brightness between fully on and fully off.
So it's not just about being in two states, but about being in a whole spectrum of states at the same time.
Exactly.
That's even weirder than I initially thought.
It is pretty wild.
It is.
But this is what gives quantum computers their incredible power.
Yeah.
A single qubit can explore a vast range of possibilities simultaneously.
Right.
And when you have multiple qubits working together, the number of possible states they can represent grows exponentially.
Exponentially.
Yurgo Schneepat really drives this point home in his article.
Okay.
He sees superposition as the key to unlocking the true potential of quantum computation.
Interesting.
Yeah.
Exponential growth. Okay, now we're talking serious computing power.
We are?
So a quantum computer with, say, 100 qubits could explore a ridiculous number of possibilities at the same time.
More possibilities than there are atoms in the observable universe.
That's a lot.
It is a truly mind-boggling number.
It is.
And this massive parallel processing capability is what allows quantum computers to tackle certain problems that would be impossible for classical computers to solve, even if they ran for billions of years.
Okay, now the hype is starting to make sense.
Right.
But what kind of problems can they actually solve? Are we talking about cracking super complex codes or simulating black holes?
Those are definitely possibilities, but it goes far beyond that.
Okay.
Imagine designing life-saving drugs at a molecular level or creating entirely new materials with properties we can only dream of today.
Right.
Quantum computers excel at problems involving optimization, searching through vast data sets, and simulating complex systems.
Oh, wow.
They could revolutionize fields like medicine materials, science, financial modeling, and even artificial intelligence.
So we're potentially talking about breakthroughs in almost every field imaginable. No wonder everyone is so excited.
The potential is truly transformative.
It is.
But as we mentioned before, building and controlling these quantum computers is incredibly difficult.
Right.
Maintaining superposition in those qubits is a delicate dance.
Okay.
The slightest disturbance from the environment, like heat or light, can cause decoherence, essentially knocking those qubits out of their superposed state and ruining the computation.
So it's like trying to balance a stack of coins on their sides in a hurricane.
That's a very vivid way to put it.
One wrong gust and everything comes crashing down.
Yeah, exactly. And that's why building practical quantum computers is such a challenge.
Okay.
They require extremely controlled environments, often operating at temperatures close to absolute zero.
Colder than space.
Yeah, much colder.
So we're not quite at the point where I can have a quantum computer in my living room.
Not yet, but the progress is astounding. Researchers around the world are working on this, developing new techniques for error correction and qubit stabilization.
Wow.
And there are actually different types of quantum computers being explored, each with its own pros and cons.
Okay.
Schneepat touches on this briefly, emphasizing the variety of approaches being taken to harness the power of superposition for practical applications.
Different types of quantum computers.
Yeah.
It seems like there's a whole other deep dive lurking within this one.
Maybe there is.
But for now, let's stick with superposition itself.
Sure.
We've talked about the science and the technology, but I'm curious about the philosophy.
Okay.
Does superposition change how we think about the nature of reality itself?
It certainly raises some mind-boggling questions.
It does.
If a quantum system can exist in multiple states simultaneously, what does that mean for our understanding of existence?
Right.
Does reality only become definite when we observe it, like, collapsing that wave function?
It's giving me flashbacks to that wave function collapsing.
I bet.
It still feels like there's something we're missing in all this.
Well, there are different interpretations of what's really going on.
Okay.
The Copenhagen interpretation, for example, suggests that the act of measurement forces the quantum system into a definite state.
Okay.
But then you have the many worlds interpretation,
Oh boy.
which proposes that every possible outcome of a quantum measurement actually occurs just in different parallel universes.
Hold on. Parallel universes.
Yeah.
Now we're really going down the rabbit hole.
I know, it's a wild idea,
It is.
but it's a serious interpretation of quantum mechanics,
Goes
and
back.
one that highlights the philosophical implications of superposition.
So every time I make a decision like choosing coffee over tea, another me in another universe is making the opposite choice.
That's one way to think about it.
My brain is officially fried.
It happens.
But this is what I love about these deep dives, going from spinning coins to parallel universes in the span of a few minutes.
Me too. It's really fascinating stuff.
It's like taking a crash course in Quantum Weirdness 101.
Exactly, and we're not done yet. but I think it's a good place to pause and let our listener absorb all this mind-bending information.
Yeah, for sure.
We'll be back soon to wrap up our exploration of superposition and its implications for our understanding of the universe.
Awesome. Can't wait.
See you then.
And we're back diving deeper into the world of superposition.
Still feeling mind-bent.
Oh, absolutely. Last time we left off with the Copenhagen interpretation and
Oh, right. The many worlds?
the many worlds interpretation. Yeah,
A lot to unpack there.
it is. But before we venture further into those parallel universes,
Okay.
I'm curious about Jorgo Schneppet's take on superposition. What were some of his key takeaways?
Well, one thing he really emphasizes is that it's not just a theoretical quirk.
Right.
It's the very foundation of a lot of emerging quantum technologies.
So we've talked about quantum computers.
Yeah.
What else is on the horizon?
Well, think about quantum cryptography.
Okay.
You know how it could revolutionize secure communication?
Interesting.
Imagine sending messages that are physically impossible to intercept without altering their state,
Okay.
thus alerting the sender to a breach.
So kind of like a lock that breaks the moment someone tries to pick it.
Exactly. It's like a self-destructing message.
Wow. So our bank accounts could be quantum safe in the future. Sign me up.
It's certainly a possibility. And Schnepphat also highlights the potential of quantum sensing.
Quantum sensing.
Yeah, it could lead to incredibly sensitive detectors for everything from gravitational waves to tiny changes in magnetic fields.
Wow.
Imagine being able to detect earthquakes before they happen,
That would be incredible.
or diagnose diseases at their earliest stages.
So it's like having a sixth sense for the universe.
In a way,
The implications are mind-boggling. It seems like superposition is the key to unlocking a whole new level of technological advancement.
I think so. And as Schnepphat argues, understanding superposition is crucial, not just for appreciating these advancements, but also for grasping the fundamental nature of reality itself.
So we've gone from spinning coins to unbreakable codes and supersensors, all thanks to this one bizarre concept.
It is pretty amazing, isn't it?
It really is.
And we've only scratched the surface.
Right.
There's so much more to explore in the quantum world.
It definitely makes you realize how much we still don't know about the universe.
Absolutely. And that's what makes studying quantum mechanics so exciting.
For sure, it's a field full of mystery and wonder.
It really is.
Well, I think our listeners' minds are sufficiently blown for one day.
I wouldn't be surprised.
So before we go, what's the one key insight you hope they take away from this deep dive?
I hope they realize that superposition is not just a theoretical concept, but a fundamental principle that governs the workings of the universe at its most basic level.
Okay.
And as Schnepphat suggests, it's a principle with the potential to revolutionize our world in ways we can only begin to imagine.
Beautifully said. And on that note, we've reached the end of our deep dive into superposition.
It's been a wild ride.
It has. We hope you've enjoyed this journey into the strange and wonderful world of quantum mechanics.
Until next time, keep those minds curious and those questions coming.
Welcome back to our deep dive on superposition.
It's the final countdown.
It is. So last time we were talking about quantum sensing and
Oh, yes, the possibilities there.
I guess before we wrap things up, what are your final thoughts on Jorgo Schneppet's article? Anything else that really stood out to you about superposition?
Well, I think what's really fascinating is how he brings together the theoretical and the practical. He doesn't just explain the concept of superposition. He really emphasizes its potential to change the world.
Yeah, for
Yeah, you know, like we've talked about quantum computers and cryptography and sensing,
Yeah?
but I think Schnepphat is really pushing us to think beyond those applications.
Okay, so what's next? What's beyond?
Well, for me, it's the philosophical implications.
Right.
If superposition is really how the universe works at its most fundamental level, what does that mean for our understanding of reality?
Whoa. Yeah, I mean, we've barely scratched the surface.
Exactly. And I think that's what Schnepphat is trying to get at.
Yeah.
He's inviting us to question our assumptions about how the world works.
It's like he's saying there's a whole other layer of reality that we're just beginning to glimpse.
And that's the beauty of quantum mechanics.
Yeah.
It's full of mysteries and paradoxes that challenge our very perception of what's possible.
Absolutely. Well, on that note, I think we've given our listeners plenty to ponder.
Plenty to ponder.
Thanks for joining us on this deep dive into superposition.
It's been a pleasure exploring this topic with you.
As always, and to all our listeners out there, keep questioning, keep exploring, and we'll catch you in our next deep dive.
Until then.